All right, let's talk about something that can save you a ton of headaches in Kubernetes. When you're running a complex app, you need certain things to be just right before your main code even starts. You need a database to be up, a config file to be downloaded, maybe some secrets to be in place. So how do you handle all that setup stuff gracefully? Well, that's exactly what Kubernetes init containers are for.
Think about it like this. A pilot would never just jump in a plane and take off, right? They go through a super detailed pre-flight checklist. They make sure everything is perfect for the journey. What if you could do that for your application right inside its Kubernetes pod? Well, you can, and that's the whole idea here.
So here's our game plan. We're going to start with the what, our pre-flight checklist concept. Then we'll get our hands dirty and look at the anatomy of an init container with a fun little example. After that, we'll talk about why this is so important for production apps, actually run it with some commands, and then wrap up by answering a couple of common questions. Sound good? Let's go.
Okay, first things first. Let's nail down what we're actually talking about. What is this pre-flight checklist for an application? At its heart, an init container is pretty much what it sounds like. It's a special, separate container whose entire reason for being is to run and finish some kind of setup task before your main app container ever gets a chance to start. Think of it like the roadies setting up the stage before the band comes out.
Now, these containers play by some very strict rules. First, they always run to completion before the main app even tries to start. Second, and this is super important, they must complete successfully. If your init container fails, your main app will never, ever start. It's a strictly one then the other process. This makes them absolutely perfect for those mission-critical setup jobs.
Okay, theory's great, but let's actually see what one of these looks like in the wild. We're going to break down the anatomy of an init container using a talking cow example. It sounds silly, but it's a really clear way to see how all the pieces fit together.
So yeah, we're going to look at a real Kubernetes YAML file. But don't worry, we're going to walk through it piece by piece. The goal here isn't to become a YAML guru, but to just understand how these different parts work together to make the magic happen.
Here's the bird's eye view of our file. You've got 4 main parts to pay attention to. We've got volumes, which sets up a little shared folder for our containers. Then you have the init container section. That's where our setup work happens. Next is the main container section for our actual application. And finally, volume mounts, which is like the glue that lets both containers see that shared folder.
So it all starts with the foundation, this shared volume. We're defining a volume we'll call data, and we're using something called empty dir. All that means is we're creating a simple, temporary folder that's born with the pod and dies with the pod. It's the perfect little digital Dropbox for our containers to pass notes. Next up, the star of the show, the init container itself. Its job is incredibly simple. We're running a lightweight BusyBox image to execute a basic shell command. All it does is print hello Kubernetes into a file called index.html. And where does it put that file? You guessed it, right into that shared data volume we just made. That's it. Job done.
And this is where the payoff is just so beautiful. Our main application is just a plain old Nginx web server. The only thing we need to do is tell it to mount that exact same data volume. The init container already did all the hard work of creating the content. Nginx just wakes up, sees an index.html file sitting there waiting for it, and immediately starts serving it. Simple as that.
Okay, so a talking cow is fun and all, but let's talk about why this is a total game changer in a real production environment. This is where init containers stop being a neat trick and start being a must-have tool in your toolkit. Just look at these common scenarios. You can have an init container that just sits there and pings the database in a loop until it's finally ready, which stops your main app from crashing on startup. Or maybe it pulls down the latest config from Vault or Git. You can even use it to run a database migration before your Rails app starts, or to generate security certificates on the fly for your app to use. The possibilities are huge. And here's a really key point on why this is so great. Unlike a sidecar container, which runs alongside your app for its entire life, an init container does its job, exits, and gets out of the way. It frees up those resources. For setup tasks, it's just a much cleaner and more efficient way to work. All right, enough talk. Let's actually do this. Let's get our hands dirty and see what it looks like to deploy this pod and bring our talking cow to life. Okay, so here's how you do it. First, you just apply the YAML file with kubectl apply. Then, if you use the -w flag to watch your pods, you'll literally see it go from an init state to running. That's our little container doing its work.
Once it's up, we use port forward to connect our local machine to the pod. And finally, a simple curl command, and we should see our result.
And boom, there it is. The ASCII art cow served up by Nginx saying hello Kubernetes. This little picture proves the entire process worked perfectly. The init container ran, it created the file, it put it in the shared space, and the main container picked it up and served it. Success!
Now, usually when people see this, a few what-if questions pop into their heads. So let's just get ahead of those and tackle a couple of the most common ones right now.
This is always the first question, and it's a good one. What happens if your setup script has a bug? Or maybe the database it's waiting for just never comes online?
And the answer is actually one of the best parts of this whole pattern. Kubernetes won't just fail and give up. The pod will just sit there in an init state, and it will keep retrying the init container based on the pod's restart policy. Your main app is completely protected. It won't even try to start until that pre-flight check is 100% successful.
Okay, what if your setup is a bit more complicated? Maybe you need to download a file, then unzip it, then process it. Can you chain these things together?
Yep, absolutely. You can define as many init containers as you want. Kubernetes will run them in the exact order you list them in the file. Each one has to finish successfully before the next one in line can even start. And only when the entire chain is successful does your main application finally get the green light. It lets you build some really sophisticated startup routines.
So, to wrap this all up, what are the big things to take away from this? Number 1, init containers run before your main app to get things ready. Number 2, they must succeed or your app won't start. It's a hard gate. Number 3, you use shared volumes to pass stuff from the init container to your main app. And finally, they are the absolute perfect tool for waiting on dependencies, fetching config, or running database migrations. Once you start thinking this way, it really changes how you approach designing your applications for Kubernetes. It gives you this incredibly robust and clean way to handle dependencies. So, the question to leave you with is, what's that one tricky startup problem you've been dealing with that an init container could solve for you first?